Hey, Jordan, what are we talking about today?
We're talking about computer vision.
Okay, I don't know what that is, so I need you to explain to me, please.
So computer vision is taking all of the senses that we have as human beings, so sight, sound, these sorts of things, and ingesting them in a way that the computer understands.
Okay, you got an example for me?
Yeah, for example, in the maritime industry, we have ships. And one of the functions of computer vision could be identifying the ships, or maybe even going further and identifying ship types or what the ship is doing. Similar to the way that we do it in the maritime industry as human beings. We identify objects, what the objects are doing, and then we take action.
Okay.
Computer vision can be also broken down in two ways. So one could be static images. So you take an image of a ship and you identify the ship itself. There's another avenue where you can use video imaging, where you have a timeline. So you have a bunch of images together, which is a video. And there's software that can unpack this and understand perhaps what the ship is doing, what it might do in the future, these sorts of things.
Jordan, could you just walk me through the how you kind of do this? Like, what's the approach to this computer vision?
Yeah, so computer vision is not new. It's actually a very old technology. It's gotten more attention lately because of these large language models, and people have more visibility on working with data and objects and images today than they did 5 years ago. But basically, it breaks down, it's not that hard to really understand. So images can be broken down into numbers. And people are like, what does that even mean? Well, if you have an image, anyone, like I'm Gen X, anyone from the 80s would know that we dealt with pixelated images back in the 80s, very simple little blocks of image. In the same way today, we have higher resolution and more complex images, but each one of these little pixels in the image can be converted to a number.
Okay.
These numbers are put together collectively, like say multiple images, thousands, tens of thousands of images. And basically you have a stack of like numbers, like matrices of numbers.
All right.
So when you put a new image in there that people don't know, hey, that the computer may have not seen before, it converts that image into numbers and then matches it with the other images that it's seen. So if it has a lot of ships in its model, it might be able to tell, hey, this is a ship based on the structure of the data. And they're so good now that they can go further than identification. Perhaps they can identify ship type and what the ship's doing and these sorts of things.
Gotcha.
There's a second element to this.
All right.
In addition to these, say, numerical images, let's call them, you can also add textual annotations to those images. So you can say, like, if you have a ship at sea, you could have a human being put more information in there. Say, like, the human could put in, like, this is a container ship, it's daylight, it's open ocean, I see a person at the manifold on the midships or something like that. When it has the human annotation, that kind of supercharges the images because these modern models can absorb those annotations and create a more refined outcome.
Okay.
This has been going on for years. People may not know this, but the CAPTCHA, when people are identifying road signs or whatever security things, they're actually training models and they're annotating models. So that's basically what, on a high level, what modeling is.
Gotcha. And so I don't want to jump ahead, but what are some use cases, especially in our industry, with this?
Well, the one thing right now is that we don't really have that many use cases in the maritime industry.
Okay.
And the reason is because in my opinion, we're not visible. we're an invisible industry. No one's really paying attention to midstream supply chains, mostly because people generally don't know about it. They don't know we exist. So there's been a lot, like the forefront of efforts right now is autonomous cars. So people really focused on autonomous cars. One of the, highest level use cases for shipping is autonomous shipping. Of course,
Right.
people think, oh, I drive my Tesla, it's like driving itself. Why can't we do this with ships? So yeah, there is a use case in the maritime industry, but I just want to say we're way far back in the Stone Age right now because we don't have the amount of material or images that we need to train the models effectively.
Okay.
Two other use cases, I'll just go really quickly, is parts identification. So you can be on a ship and you say like a typical challenge is like you have a ship that's 15 years old. It was built who knows where, and they have this like one-off part, and like, how do I get this part? Traditionally you go out to the stevedore, you go out to a technical person and you say, can you find me this part? And it's just, and then they deliver it and it's the wrong part. So one thing you could do is like when you're in the engine room, take a picture of the part, and then perhaps you have a classification situation where you can correctly identify the part and the provider of the part. That's number two. And then the third one is risk analysis. So you could do hazard identification, simply take a picture of a space on a ship or something, and perhaps the model can identify the risk in the environment it's in.
But you mentioned that as far as using this in shipping, that we still have to collect a lot of images around this. How do you initially train these models?
So you have to collect a large amount of images, 10,000, say 10,000 images. The way that they do it today is that you have to annotate the images. So you have to have a human being. Now we can use AI to do this. It's a
right.
But basically annotate the images to describe what's being seen. And then there's another concept of metadata. You identify the time the image was taken, all these different things around it. Maybe the geolocation, the geographical.
Right. Do you have any controversial opinions or big statements around computer vision?
Yeah, so computer vision right now in 2025, we're almost in 2025 here, is that it's highly biased and incorrect. I'm going to go out on a limb here and be like a little bit of maybe a jerk and say that people building these models they're just using like tons of data that they scraped off the internet. It could have come from anywhere, Facebook, Twitter, who knows? And, it could be images that are just bad images, or it could be like an overwhelming number of images that have one concern, like Instagram images of somebody traveling somewhere. So when you try to apply these general models to a specific domain or specific use case, they don't work. They really don't work. And I think people would be shocked to see the lack of efficacy of these foundation models in a domain situation.
Yeah, that makes sense.
They're horrible. Yeah, so we have a lot of work to do. Even though you're going to see on the website, we can do this, we can do that, everything's great. We can do it all. Probably right now that's not true. It's BS.
No, I mean, if you read a Maritime Tech website, there's nothing that can't be done right now. So I appreciate that. All right, Jordan, this is good. Thank you for your time and for bringing this topic to light.